Hello guys, welcome back to my channel and this second video. So we are continuing top interview 150 lead code questions. So we were doing graph problems. So let's see what we have today. Let's start with this clone graph. I am seeing this problem for the first time. So yeah, let's deep dive into it. Problem number 133, clone graph. Given in a reference of a node in a connected unidirected graph, return a deep copy clone of the graph. Each node in the graph contains a value and list node of its neighbor. Okay, cool. Test case format. For simplicity, each node's value is the same as the node's index, one index. For example, the first node with value 1, the second node with value 2, and so on. The graph is represented in the test case using an adjacency list. Okay, an adjacency is a collection of ordered lists of the which lists are okay. The given node will always be the first node with value 1. You must return the copy of the given node as a reference to the clone graph. Okay. Adjacency list. Okay, output. Cool. There are 4 nodes in the graph. Okay, so let's see. Now it says that the node's value will be the same as the node's index. So that means if we see 2 and 4, that means the first node is connected to 2 and 4. 2 and 4. The second one will be 1 and 3. Okay, got it. So what we will be given is that a node, and it says that the given node will always be the first node. Cool. Okay, let's see the questions. Original graph, you can't return the same graph. Okay, this looks like a clone. The nodes and new graphs looks the same. Okay, the nodes were cloned but the graph is messed up, doesn't have safe connections. Okay, we have to maintain the connections. Definition of a node. Okay. So as far as I have understand till now is that we will be given the first node, that is this, and we have to return a new graph from this. Okay. So let's start with the drawing. Basically draw. Okay, so let's create a list. Okay, so first one will be connected to 2 and 4. Okay, let's create a map. So this will be given and it will have a list of node. Okay, so let's maintain a I think Q will do the trick. So it will have 2 and 4. So let's push 2 and 4 to the Q. Okay, let me just think for a while. 4, okay, 10, 4, 2, we will go to but if we get this node, okay, it will have a list of node. Okay, so if we get 2 out of these, then for 2 we will get the other nodes. Okay, we will get 1 and 3. Similarly for 3 we will get 2 and 4, 2 and 4 and 4 we will get 1 and 3. 1 and 3. So first we will create a map. So this will be a map, and from this map we first we will create the adjacency list or map, whatever you say. From this we will create a node, a new node actually. Let's remove this for now. Sorry. So, we'll take the first node, 1. I think we have to just create the map. Yeah, we'll be given a node and we'll just have to create a new adjacency list. I think that's it. Yep. So let's continue with this array list of integer array graph new array list. Yep, but we don't know what will be the size, right? So let's make it list of integer. Okay, then first initiate it, but yeah, again we don't know how many nodes we have. I think we have to first count the number of nodes that we have, then we can initiate it. But can we do it as we go? Let's see. Can we create a map first? Let's try with a map, because that doesn't need a size. So it will have list of integer. Instead of a node, we can also take it integer just to mark it new hash map. Okay, now we have the node. Let's take the list of node neighbors. Let's take it neighbors equals to node dot neighbors. So this will be neighbors. Okay, now we know that the first node, we will have the first node. So okay, so it can be 0. Cool. That means we can have a empty node as well. Okay, we will take the edge cases later. Let's just iterate over this node of, let's take n and br. We will take map put if absent. This is a class that says if one is not there, then first put it, then add it to the list. New, let's take it node. Put it, then new, new, will it be map.get? I don't know. See, I actually confused with the syntax since we don't have one right now. So how can we put it here? I think it will be new list dot add n. I hope this works. I'm not sure. Okay, now what we have done is we have created a first node. One, we put it 2 and 3, 2 and 4. But for this we have to do it until we have a, but we have to put it this, so I think we have to create a queue. Okay, so 2 and 4, so 2 and 4, so I will fetch 2, put it 1 and 3. Okay, so that means we have to create a queue also. Let's create it. It will be integer or node. It will be node queue equals to new, sorry, it will be linked list then queue dot add node. If node is given, we will check the case of the empty nodes later, but yeah, then we'll loop through this while queue dot size is greater than 0. Then we will first fetch the current node, queue dot poll. Instead of add, let's use the method offer. Current, and let's put it map dot put if absent 1, sorry, current dot value. Let's take it, I am confused with the syntax, so let's just take the help of AI. There's no wrong in using AI, I guess, but yeah, of course you can't use it in the interview. So let's just check the syntax, how to add first element. Of course it will be improved as you go, as you keep practicing. So yep, this is my first time, so let's see. New hash map, compute if absent k, all right, so it should be recommended way is compute if absent. Still very slightly more verbose, map.get. okay, so for this you have to do in 2 steps. Okay, first you have to initialize, then you have to add it, but if we use the compute if absent, then we can do it in the first time. See, we have learned something new. So it should be compute if absent, then k, it is a lambda function, it's a new array list dot current. Okay, new, it should be hash map. Okay, new array list, then dot add current. Cool. Now let's iterate over the node of the neighbors. Current dot neagh bors. Okay, so it will be also compute if absent, then table dot val k new array list dot add. So it should be I think it just a minute, we add the current element and first we will add it to the graph, right? No, just a minute. Compute if absent, we get the current value. Add should be not current, yeah, it should be list of node, it should be current dot urc. We can add it directly, right? Yeah. Now for neighbors, we will add it to the queue actually. Queue dot offer neighbor. So what we have done is we added the first element in the queue. We added the first element, then we just a minute, let's try run it. We added the first element, that is 1. Okay, since it is the first node, it is given to us. then we removed it. We removed 1. We add it to the map. This one, and we added the neighbors. That is 2 and 4. 2 and 4. We add 2 and 4 in the queue. Alright, now in the next step we remove 2, add 2, and we add it to the 1 and 3 to the map, and we add 1 and 3 in the this one. Okay, we remove 4, we add 4, and we again, alright, 2 and 3 and 1 and 3. Just a minute, something is wrong. 2 is 1 and 3, 4 is 1 and 3, 2 is 1 and 3. Okay, cool. 4, we added 1 and 3, then we again 1. Okay, so what we have to maintain is we have to keep track of the visited array, visited nodes. Okay, that means if, or we can say if it is present, then don't add. Yeah, that means map dot contains key of nbr dot val. Just continue. That means in the first step, when adding 2, 1 and 3, 1 is already there, so it will not be added. Continue. 3, it's not there, it will be added. 4, we have done 1 and 3, then the next step will be cut out 3, add it, 2 and 4. Now 2 and 4 is present, 4 and 3 is present, 3 is not, so it is there. Okay, so like this it will be over. Cool, so the map is done. We just have to create an adjacency list. Okay, let's take array list of integer. Okay, so we have to first we have to we have to return the first node. Okay, we can't return something like this. So what we will do is, yep, let's iterate over to for let's say int I of map dot key set, and we will create a new node first. Let's take to 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 get a first node, we'll say if wait, how can we fetch the first node? How will fetch the first node? Let's have node first equals to, let's keep it this, and di equals to 0. Or we can say that node of current equals to new node. We can create a node with array list of neighbors. Okay, we can initialize it directly. So let's give the integer value as I, and we give the map dot get list of node as the list. Now if first is null, then we assign current equals first equals to current. Then we return first. I guess this will work. Now let's see what will happen. Now let's try run it, what will happen for the empty cases. Now we have to this one, note that the input contains one empty list. The graph consists of only one it fell, and it does not have any neighbors. Okay, cool. So we initialize this map, initialize the queue, we add the node. Okay, we add the node. Queue size is greater than 0. Okay, node current node is queue.poll. We fetch this. Now we have current dot val will be always 1. Okay, add neighbors, it doesn't have any neighbors. Okay, it will be 0, so nothing will be added. First key set 1. I guess this will work. Empty graph, let's see. Node, what will be given? Will it be null? It does not have any nodes. Let's try to run this. I don't know what will be happening. Expected something. Contains key. Alright, it should be within a if condition. If contains key, then continue. List node cannot be converted to node. Okay, current dot neighbors. But current dot neighbors is a list of node, right? So why it's giving this? Let's see. Well, list node can be converted to array list node. Something is wrong. map.compute if present. Did we did something syntax error? Let's see. If list node, then array list dot add current. Add current. Okay, so current dot neighbors. New array list. So it is add. Okay. Let's do one thing. We use the second one. Okay, put if absent. Then we do a list of node, right? So we can't add it to this like that. Since it is list of node, we have to do have to use put. Okay. Okay. Let's do one thing. Map dot put if absent current dot fell. Okay, let's do directly map dot contains key current dot fell. If doesn't contains false, it is true. Then we do map dot put current value to current dot neighbors. Will it work? Let's see. Okay, so this one is done. Another we are getting syntax error in this. Okay, map.get. Map is list of node. Okay. List node cannot be converted to array list of node. Doesn't it the same? Map.get I. Get I is list of node. Array list of node. Okay. Okay, it's a list. It's an array list. Okay, got it. What we can do? We can do is we first create a node, then we put it there. Okay, let's just first create the node, then current dot neighbors equals to map.get I. Let's see, will it work? Might not have been initialized. Okay, let's initialize it to null. Because local 4 is null. Okay, so we got this, the edge case. Okay, but if it is null, then okay, if this is empty, I mean node is empty, return what? We have to return something, so it will be will it be 0 or what? I mean return null. Yeah. Okay, so some cases it's done. What is it? It was not copied but a reference to the original one. Okay, so what you mean is that we put it in the queue, new node I. Okay, new node key set to so it's happening, but new node are not occurring. Let's see. So we have to create a new, when we are putting there we have to contents key, you have to put new neighbors. We can't use the current dot neighbors because obviously we have to edit. So let's see, if it is not, then we can do what is adding there. We can add it to the map.get current.val add new node current new node neighbor dot val and neighbor dot, I think this will give again the error list to list node error. Let's see. Yeah, I thought so. This cannot be uploaded to given types. Contains key put. Okay, it should be new. I thought so. Let's start with, let's initialize it with this. Something a copy of you must return a copy of all the nodes in the original part. Okay, something is definitely wrong. Let's see. We are doing it right, but somewhere we are not creating the neighbors. Okay, let's try run it. Try run it again. We at least we add the node. We fetch the current node. Okay. We initialize the map current.value. Okay. For the neighbors, if neighbors is there, okay, if map contents, we are initialize it right, if there map dot contains key, we are skipping it, right? So we initialize it one. Okay, map.get current value. Let's do this. Okay, again wrong answer. So when we are iterating to the neighbors of 2 and 4, okay, we are creating get.val to this and add new node of this. Okay, can't we add it here? New node, let's create it here only. Let's see. Let's undo this thing. Okay, while adding it to the neighbors, we can do new node, and it is initializing new array list. So what we can do is we can add it to the neighbor. Can we? But we have to add it this node, current node. It is getting tricky. We have to add it node. Let's see where we are doing the mistake. Where is the mistake? Leetcode 133. We're using list node using correct for this problem. Graph nodes are objects, not values. Okay. To be unique, cloning requires a one-to-one mapping between original nodes and clone nodes. Okay, current mapping must be node and node. Okay, we are not cloning neighbors. Okay, this story refers to the original neighbors, not clone the user. So even if a code returns something, it will still point original validating the problem. Okay, breadfast logic is broken. Continue on. However, you are making no sense visited before cloning. If you are using val instead of node identity, you can skip valid nodes if two nodes share the same value. Okay, you create new nodes but never connect them. Okay, you return incomplete graph. Cool. Returning just the first node is correct only if the graph is properly connected. Yours isn't. Correct BFS solution. Okay, let's see. If node equals to null, we have done this check. It should be node q. Okay, clone the first node, put node is a new node. Okay, then q.offer. Okay, so we have to clone one by one, not something as node to list. Okay, got it. Then q, we fetch the current node, we iterate to the neighbors. q.offer node, which node is this? Okay, this one is the node. Current node, if map contains key, if doesn't contains key, then put neighbor new node q.offer neighbor. Okay, map.get current node dot map dot get the current node dot neighbor dot add map. Okay, what? We fetch the current node, then we add it to the neighbors. Of map dot get neighbor. Okay, we just link to the underneath to the other node. Okay, map dot get node. Yeah, I do have a idea what the code is doing is we create a map of 1 to 1. I mean, we don't keep the list 2 2. Got it? Then what happening is that when we are creating the node, alright, when we are creating this node, creating the neighbors, actually we are creating is that we are adding into the neighbor is that we have this, right? We have the original 2 and 4, so this represents 2 and 4. So what happening, we are fetching this to this neighbor, we are adding these two. We are adding the reference of this. Yeah, I got that something. Yep. It is get neighbor. So let's try it once more. We kept the check if node equals to null, then return null. We initialize the map. Now it will be 1 to 1 mapping. Hash map. We initialize the queue of node. Queue equals to new. We add the node to the first one, but first I think we have to add it. Let's see, while queue dot size is greater than 1, we fetch the current node queue dot pull. Yep. Then we add it to the map dot put current with new node current dot value. Okay, now we iterate the neighbors. Node neighbor, since current is the original node, it will have neighbors, energy is BRS. Then we check if map it, we check that whether we already have the node or not. Contains key neighbor dot val, neighbor dot val or neighbor. It's neighbor dot val, I guess. Yep. Okay, it is neighbor, and it should be false. It's false. Then we put map dot put neighbor with new node neighbor dot val. We add it. Okay, so we are creating the one-to-one node. We are adding neighbors. If doesn't contains, then we are adding neighbors with creating neighbors with new node pool. Now we have to add neighbors, right? Map dot get current dot value. Just a minute. Current. It's current dot value, right? Not current. We're cloning the first node first. Okay, we're cloning the first node first. Map dot put node new node dot value. So we are getting it back. We are not adding it. If neighbors, now node current dot neighbors, we are iterating to the neighbors. Contents key doesn't have, then put a neighbor with a new node with a new neighbor. Then q dot offer, put it there. Then we first get the node, then we add it to the NEIGSBORS neighbors dot add. Map dot get neighbor. You created a new node, then we added new node to the current node. Okay, understood. Then we first return the, then we just return the first node. Map return map dot get node. Okay, something is still wrong. Okay, why it's greater than 0? Okay, it runs. Submitted. So it is done. We do took help of ChatGPT, but yep, it will come eventually as we keeps on practicing. It will come naturally. We will understand the pattern, and yeah, see you on the next video.